Okay, Bismillahirrahmanirrahim. So now we start our topic 5, pipe system. Okay, so pipe system, you also use the same formula, okay? The same formula that you have learned in chapter 3 and chapter 4, okay? So pipe system, you must understand that the concept of hydraulic grade line and also the energy grade line, okay? Analyze flow in single pipe, pipe in series and pipe in parallel, and analyze loop pipe network using Hardy cross method. So this Hardy cross method is your project group. Okay, so this is based on your project group. So in this chapter 5, we just learn the hydraulic grade line and energy grade line and also the pipe series and parallel pipe. Okay, so two method of pipe series, okay, analysis in pipe, pipe in series and pipe in parallel, and also the hydraulic grade line and energy grade line. Okay, so energy line or and hydraulic grade line. Okay, so this is based or refer to energy line here. Okay, P1 over specific weight plus V1 squared over 2G plus Z1. Okay, actually the energy line shows total head for a certain cross section in system. Okay, you have learned this formula in chapter 3 and also chapter 4 based on Bernoulli equation or energy equation. So you know that this formula, okay? So this is called energy line. Okay, this is called the energy line, EL. Okay, so in your final, okay, maybe they have the definition. What is the definition of energy line? And also what is the hydraulic grade line? Okay, so this is hydraulic grade line based on this formula. Okay, pressure 1 divided by the specific weight plus Z1. Okay, so hydraulic grade line shows a piezometric head for a certain cross section in a system. Okay, actually based on this figure here, okay, this line is the energy line here. Okay, the red line here that I draw here, this sketch here is energy line. The hydraulic grade line is here, the blue line here. Okay, so this is the hydraulic grade line. So based on the section 1 to flow from 1 to section 2 here. So they have the energy line, they have the hydraulic grade line, and so must include the Bernoulli equation. Okay, so now we look at the slide 5 to 9 shows the example of EL and HGL. Okay, so this is example 1 here. Okay, the example 1 here is energy line. Okay, so energy line is the blue line here. Okay, and the HGL is the right line here. Okay, so this is the example 1 is based water flows from a tank to atmosphere. From this tank, okay, through this pipe here and to atmosphere. So you have learned this concept in chapter 3 and 4. Okay, based on the water flow from the tank, okay, to the atmosphere through this pipe, okay, along this pipe. Okay, so this is also include the HF. Okay, so along this pipe, so it's include the HF, okay, friction loss. Okay, and also based on this part here, based on the HM. Okay, so in chapter 5, so must include the HF and the HM. Okay, the Bernoulli equation. Now look at the example 2. Okay, example 2 is the drop immediately in total energy head. Okay, based on from water tank here, okay, flow through this pipe, okay, and have the turbine or pump, okay, but this is based on turbine, okay, and insert to the reservoir here. Okay, so the energy line here, okay, the black line here is energy line, okay, and the dot line red line here is the HGL. Okay, so when in case in your final have this figure, okay, kalau dia tunjukkan this figure, so you must sketch the energy line or HGL, so you must draw this line. Okay, this line based on the EL and also the HGL here. Okay, when this okay, at the turbine here, okay, so they have the drop here. Okay, so the drop is called head. Okay, head loss in turbine. So the head loss in turbine, so they have the drop here. Okay, the drop, and then we have the line here, HL, EL and HGL. Okay, maksudnya you kena sketch lah kalau in final dia ada tunjukkan this figure based on two tank. Okay, and the water flow from the pipe here and also the turbine. So you must draw the EL and HGL line here. Okay, so def look at the example 3. Okay, the example 3 is based on fluid flows through a nozzle. Okay, so you have learned the nozzle in chapter 4. Okay, the nozzle is based on the minor losses in nozzle. Okay, so based on the nozzle, so maybe the nozzle based on the from the bigger diameter of pipe, okay, to the smaller. Okay, so this is velocity increase when there is a contraction. So this is based on contraction. Okay, you have learned in chapter 4. Okay, in diameter of pipe. Okay, so this is the energy line. Okay, the black line here, and the red dot line here is HGL. Okay, so you can draw. If question give you this figure, give you the nozzle, so you must sketch the EL line and HGL. So you just draw this line. Okay, kalau dia bagi in dalam soalan, katakan dia bagi example 1 or example 2 or example 3. Okay, so you must sketch the EL line or HGL line. So you must sketch here. Okay, you can get the 2 marks. Okay, maksudnya ada so the previous final exam have the question like this. So they give you the figure. Okay, figure in example 1, 2 and also example 3. So you must draw the EL and HGL line. Okay, so now look at example 4. Okay, so the example 4 is the water flows through two types of diameter pipe. Okay, from this tank, okay, flow to the pipe, small pipe here to the bigger pipe here. So they have the from the smaller to the bigger. So they have friction losses along the pipe and also HM. So that's why we have HF. Okay, HF2. Okay, HF1. Okay, this is HF1. So HF1 is in pipe 1, HF2 is in pipe 2. Okay, so you draw this blue is EL line. Okay, the blue line, and the red line is the HG line. Okay, based on this pipe. Okay, so kalau the pipe kecil, so based on the smaller pipe here to the bigger pipe, so EL line is drop here. Okay, they have the drop at the part in based on the here. Okay, they have the drop in EL. When the HGL, so they must increase here. So they go to top here. So dia akan naik sini. So based on this, okay, from the smaller pipe to the bigger pipe. So they have the drop here. Drop for EL and up to the HGL. Okay, ni lah contoh you kena buat lah. You kena sketch. Katakan dia bagi this figure, okay, from reservoir, okay, follow water flows through two types of diameter pipe. So you must sketch the line of EL and HGL. So you just draw this line. Okay, and also the drop here. Okay, the drop here based on this nozzle. Okay, so the drop for the HGL is at this nozzle. Okay, so you get the marks based on this line, EL and HGL line. So now example 5 is based on they have the pump also. This is a pump and also the turbine here. Okay, so the water flow from the tank A to the tank B here. So they have the pump here. So pump, that's the function to increase the water level here, and then the EL line, so we just, okay, here, okay, drop, okay, from the, up here and drop, decrease, okay, and also the HGL is also decreased. Okay, so this is the based on the, because they have the pump and then the turbine here. So the pump and then at the turbine here, so they just drop at this here. Okay, at the drop, and the straight line here is EL and the HDL. Okay, so at this pump, so EL and the HDL is the same line. Okay, so maksudnya kat sini adalah EL and the HDL is the same line when using the pump. Okay, when using the turbine is also the same here, but it's drop. Okay, turbine is drop, pump is to increase. Okay, at this part here, based along the pipe, because this along the pipe, so the EL and the HDL is the parallel here. Okay, so this using the Bernoulli equation here, so they have used here, and H pump, okay, H pump plus H pump when the turbine is minus here. Okay, so in part here H pump minus by H turbine. Okay, in case dalam soalan dia ada tulis pump and also the turbine. Okay, in case they have include the pump and also the turbine here. Okay, and must include the HL. So you must remember that HL is also plus HF and also the HM. Okay, so this is for HL, head losses. Okay, now we look at the EL and HGL. So this is the point here. Okay, EL always higher or same level with HGL. Okay, same level is based in this part here. Okay, so kalau dia ada tinggi ataupun same level, so based on this same level, so this same level. Okay, always higher or same level, so always higher based macam ni lah. So dia tinggi sikit daripada EL and also HGL. Okay, so EL always higher or same level with HGL. Okay, the difference between two lines is the value of kinematic energy head. So V2 squared over 2G. Okay, over 2G here. So major losses cause EL and HGL to decrease gradually. Okay, minor losses, okay, cause EL and HGL to decrease rapidly. So this is the point here. Okay, if you have the question that explain the difference between differentiate the EL and the HGL, so you can different that the EL and the HGL. Okay, so use of pump. So bila dia guna pump, so line increase immediately. Okay, when use of turbine, lines decrease immediately. So this is based on, the point is based on the example here. Example 5, example 4, 3, 2, and 1. Okay, so based on this example here, so we can define that, we can summarize that EL and HGL is this 6 point here. Okay, so you can point as the theory for EL and HGL. Okay, so using the energy equation from A to B here, okay, this is actually example 1. Okay, so this figure is example 1. Okay, so we use the Bernoulli equation, okay, energy equation from A to B. So we have here, okay, Z, okay, plus the HF and HM. So this is also you have learned in chapter 3. Okay, so kita akan guna balik in chapter chapter 3 and chapter 4. Okay, you have learned the chapter 4 plus HF plus the HM. Okay, so use the same equation or formula in this chapter. Okay, chapter 5. Okay, so using this, okay, this figure, okay, based on from A to B, so you must know that the energy equation here. Okay, so this A is open to atmosphere and also B is open to atmosphere. So PA, VA, PB is 0. Okay, because open to the atmosphere is also 0. Okay, so you get the 0 here. Okay, so they just only have the ZA, ZB minus here and equal to VB squared over 2G plus the HF plus HM, okay, based on the HL here. Okay, so the ZA minus by ZB is also the head. Okay, HS. Okay, maksudnya ketinggian dia. So from ZA to ZB, HS here. So we have VB squared over 2G plus the HF is FLV squared over 2GD and HM is 0.5 V2 squared over 2G. Why we use the 0.5? Because at this square edge, okay, the square edge is the K entrance. Okay, this is the core K entrance based on the square edge is 0.5. Okay, so you must refer back to chapter 4. Okay, sebab tu saya terus masuk chapter 5. Okay, because you have finished the chapter 4. Okay, so use that formula in chapter 4, then you use the same equation in chapter 5. Okay, sebab tu saya masuk terus in chapter 5. Okay, so this slide I will upload in author. Okay, so just maybe by this, okay, or tomorrow, okay, ataupun saya akan masuk nantilah besok ataupun petang ni so also the record video. Okay, so I'll give you. So now we have the HF and HM, so we use just calculate here. Okay, and until you get the HS is VB squared over 2G and plus 1 plus 4 FL over D and plus 0.5. Okay, actually based on from this here, so you get the formula here. Okay, so HF is VB 2G Q1 plus FLD FL divided by D plus 0.5 actually is the, okay, actually this is the, okay, this the circle here based on for this, okay, this formula here. Okay, and we just assume as a K. Okay, we assume that 1.5 plus FL over D. Okay, so we get as assume as a K here. Okay, so as a K. So BB here, so we as the K here. So actually is the K. Okay, so the K is the 1.5 plus FL over D. So BB is the here. Okay, so to get the QAV, so A times by the V. V is 2GHS divided by K. K is here 1.45 plus FL over D. Okay, so kita assume dia lah. Okay, kalau tak nak assume pun we just use direct this formula. Okay, so we just use that direct formula. So we get the Q A times by 2GHS. Okay, HS is ZA. Okay, actually the HS is ZA minus by ZB. Okay, so we get the 1.5 plus FL over D. Okay, senang ingat yang sini lah. Okay, tak payah nak assume. Okay, so now we just look at the example 4.1 here. Okay, determine the discharge of water flows in the system. Okay, so this is the system base that I mentioned here using this. Okay, so from this system, so we look at the example here. Okay, so the example from this reservoir, water flow from this tank A through this pipe, okay, and open to the atmosphere at the B here. Okay, so we get the HS is, okay, ZA minus by ZB. Okay, HS is ZA minus by ZB. See, is the 10 meter sama dengan 10 meter. Okay, that is 10 meter. KF is 0.005 and L is 100 meter. D is 0.5 cm. Okay, so determine the discharge of water flows in the system. Okay, to get the Q. Okay, so using this okay, using this formula, so you get the value. Okay, so you just use that formula. Q is equal to V is 2GH 1.5. Okay, 1.5 actually here 1.5 plus FLD. Okay, K is 1.5 plus FL over D. Okay, so you just use this K. Okay, take it from the previous slide. Okay, in test the formula must be derived. Okay, so the formula must be derived from Bernoulli equation. Okay, so kalau dalam soalan nanti dia tak bagi so this not given this V. Okay, you must derive from this equation. Okay, maksudnya dia tunjukkan lah. Maksudnya you kena gunakan this Bernoulli equation until you get this value here. Okay, until you get the HS and this value. Okay, maksudnya you kena carilah based on the Bernoulli equation. Okay, cuma bila kita dah cari based on this previous slide, that's why the example here we just use that formula. Okay, so HS is ZA, okay, plus ZV minus not plus minus sini ZA. Okay, because the B is at the datum 0. Okay, ZA, the height of the ZA is 10. Okay, minus by 0. So we get the 10. So this is minus. Okay, so just correct. Okay, ZA minus by ZB is 10 cm. So F 0.005, 10 meter, not 10 cm. Okay. Okay, typo So this is typo error. Okay, 10 meter, F 0.005, L is 100 meter, D 0.5 cm, D is, okay, cm, 0.5 cm. Okay, K using the 1.5 plus FL over D. Okay, so FL, F 0.05 times by the L is 100 and the D diameter is 0.005. Convert in meter. So you get the K is 101.5. Okay, so just put the value here to this the formula to get the velocity. So you get the velocity is 1.39 meter per second. So you get the velocity. Okay, after you get the velocity, so you find the Q. Okay, based on the AV, so you get the value here. Okay, untuk chapter 5 here, okay, senangnya just direct. Okay, direct calculation based on Bernoulli equation. Okay, based on the here, okay, the energy equation from A to B. Okay, so you must know, remember this one. So this one, okay, so include HF and HM so ingat. So kalau dalam soalan dia beri this based on this tank A to the tank B and the A and B is open to atmosphere, so you can use this formula. Okay, so you can use this formula. Okay, derive from the energy equation. Okay, and then you can get the Q. Okay, this is example. Okay, so this is example. Use the water flow which connecting with two reservoir. Okay, yang tadi this one is based on from the tank A to the B. Okay, through the pipe. Okay, so open to atmosphere. A and B is open to atmosphere. So the concept of Bernoulli equation is here. Okay, based on this one. Okay, but for the two reservoir here, connecting with two reservoir A and B are also open to atmosphere. So you must use the energy equation from A to B based on mass plus HM plus HF. Okay, so the VA, okay, the velocity at A. So PA is not mentioned that PA is, okay, maksudnya dia tak mention that PA is 0 or PB is 0 So you must include the PA and PB here. Okay, so so dia ada lah. So FLZA, yeah, okay. Okay, so dia ada based on just only have the ZA, sorry. Only have the ZA, ZB, and also the HM and the HF here. Okay. So the open atmosphere dia adalah sini 0 Okay. And also PB. Silap ni Okay. Okay, maksudnya CD kat VA kosong, ZA ni ada So ZA dia have value. Dia typo maksudnya dia terlari Maksudnya saya punya this formula dia terlari the arrow here. Okay, so the ZA they just only have the ZA. So they have the ZA, the ZB plus HM plus HF. Okay, dia ada ni lah nilai dia. Okay, so the HM, the HF. Okay, so HM, so they just have the HF here. Okay, for the minor losses, they have two minor losses, that entrance and also the out here, exit and also the out here. Okay, so the exit and out, you must refer to the chapter 4 to get the KE here. So KE is 0.5 and also 1 here. Okay, so 1 here. Okay, based on KE is 0.5 KE and K out here, K out is 1. Okay, so HF you have FLV squared over 2GD. So kena ingat so you must remember that the flow must include the friction loss along this pipe and also the minor losses. Okay, minor losses based on the K entrance, exit here and out here. Okay, so that's why include that this is HF. Okay, this is HE. Okay, entrance, and this is the minor losses in out. Okay, so that's ZA minus my ZB is we just use the HS here. Okay, so VB squared over 2G. Why we use the V? Because the V at the pipe, okay, enter pipe from A to the pipe here at the B. So we have the VB here. Okay, so using the velocity V here, 0.5 plus FL over D plus 1 here. So we get the V here. Okay, so same as the 1.5 plus FL over D here. Okay, we assume as the K. Sama macam the previous, same as the previous slide. So we get 1.5 plus FL over D here. So we get the Q is 2GHS over K. So the same. Okay, maksudnya you get this formula here, okay, based on the energy equation, okay, from A to B. Okay, so this is example. Okay, this example 5.2 is based on this figure. Okay, based on that reservoir, to determine the difference elevation level between two reservoirs which is connected by single pipe of cast iron for 1 kilometer length. Okay, the length is 1 kilometer. So discharge and diameter is given as 0.01 meter cubic per second and 5 cm for diameter. Okay, and the kinetic viscosity is here. Okay, so first you must find the velocity. Okay, velocity based on the Q given here. Okay, the Q given and also the diameter. Okay, so diameter 0.05. Okay, meter. So you get the value of velocity 5.09 meter per second. Okay, you get the velocity, and then you get the Reynolds number VD. Okay, to get the Reynolds number here, so you must refer to Moody chart. Okay, because the F is not given. Okay, so why you must find the F? Because in HF, okay, in HF here must also have the LF. Okay, so that's why you must refer to Moody chart. The relative roughness E over D 0.25 divided by 50. Diameter is cm, but convert to mm. Okay, so you get the value of 0.005. Okay, so refer the Reynolds number and 0.05 in Moody chart. So you get the F is 0.03. Okay, so you must refer to Moody chart. Okay, after you get the F, so you use the K here. Okay, K is based on the here. Okay, the value of K here 1.5 plus FL over D. Okay, you just put here put the F and the L and the D here. Okay, so you get the value K is 601.5, and then just put the V here. Okay, so the V is equal to 2GHS over K. So you want to find the HS. Okay, actually HS is ZA minus by ZB, because you want to find the determine the different elevation. Okay, maksudnya perbezaan ketinggian. So determine the different elevation level. So you get the HS or ZA minus by ZB is 794.28 meters. Okay, so you get the value here. Okay, so now we look at the example 5.3. Okay, so the example 5.3 is in Earth. Okay, so using the reservoir here also, okay, but also include the pump here. Okay, in a firefighting system, a pipeline with a pump. Okay, the pipeline here is, okay, the pipeline here using the pipe. Okay, and the pump here. Okay, so find the flow rate. Okay, find the Q when the pump develops a head of, okay, dia guna feet maksudnya untuk this is using the 80 feet. Given that we may express the friction head loss in the 6-inch diameter pipe by HF6 and the friction head loss in the 4-inch diameter pipe by HF4, neglect minor losses. So kalau dia mention here as the minor losses, neglect minor losses, no HM. Okay, we just only have the HF. Okay, so the sketch the energy line. Macam ni lah soalan dia, kalau dia suruh sketch the energy line and hydraulic grade line, so you must sketch. Okay, find the pressure head at the suction side of the pump here, and find the power delivered to the water by the pump and compute the power of the jet. Okay, soalan macam ni lah. So, tapi biasanya in your final is SI unit no US unit. This is US unit, inch. Okay, so you can convert to meter. Tapi dalam ni tak apa kita gunakan feet dulu. Okay, you try using the feet here. Okay, so you must know that you must using the energy equation between A and the C here. Okay, A to C. From A to C here. Okay, so energy equation between A and C. So you must draw use the Bernoulli equation. Okay, energy equation PA ZA plus VA squared over 2G must minus the pump here. Okay, minus by pump here. Okay, pump HF6. Okay, plus the H pump. Okay, H pump here. Okay, H5 5C is the friction loss in the pump. Maksudnya dia ada friction loss in the pump. So using this equation. Okay, and the HF is, okay, using for the ada dua pipe. Okay, that's why the friction loss in this pipe here. Okay, and also the friction loss in this pipe. So that's why actually the friction loss, okay, the friction loss here is based at this part here plus HF6 plus HF4. Okay, but this HF4 and HF4 and 6, okay, just go to the left side. Okay, dia bawa pindah ke left side. That's why we get the negative HF6 and negative HF4, because to put at the pump here. Okay, maksudnya sebenarnya HF6 and the H4 is based on the right side here. Okay, based on the plus here. So we just put to the left side here. So we get the negative. Okay, so we get the energy equation between A and C. So we know that the PA is 0. Okay, VA also 0. Okay, PC also 0 because it's open to the atmosphere. And the VA. Okay, so they just have here. Okay, so 0, 7, the ZA is elevation is 70. Okay, and negative 5 here based on HF6. Okay, negative, and plus the HF4. HP is this one. Okay, HP, and this one H4 here. Okay, and equal to PC is 0, and ZC is elevation is this one. Okay, ZC, and plus VC squared over 2G. Okay, so dia nak dapatkan to get the express the velocity in along this pipe. Okay, so we get the here. Okay, until we get this formula. Okay, so express V4 and V6 in terms of VC using the continuity equation. Okay, so you must using the chapter 3 continuity equation. Okay, so we know that A1 V1 is equal to A2 V2. Okay, so ni daripada sini ke sini adalah sama lah, maksudnya based on the pipe here. So we use the continuity equation. So we use the A for V4 is equal to AC VC. Okay, maksudnya pada area pipe in 4-inch diameter is equal to area area at the C here and the VC here. So we use this continuity equation. And we get the V4 in terms of VC. Okay, we just put as the one here. Okay, A, B, and AC. A6 V6 is equal to AC VC. So we get the VC as the 2 here. Okay, so we get the energy equation between A and C. So we have the value here. Okay, based on this value here. Okay, the value here. So we get this value. Then just put the V4 is equal to 0.5625 VC and V6 is 0.25 VC. So just put in this formula. Okay, so you get the value of VC is in here. Okay. So kalau dalam feet, the G is 32.2 feet per second squared. Okay, for this is in US unit. Okay, so you get the VC and then you use the Q is equal to ACVC. So you get the value of Q. Okay, so you get the Q here. Then sketch the energy line and hydraulic grade line. Okay, after you get the value, so you must sketch the hydraulic grade line and EL. Okay, so you get the HF here. Okay, so HF, so VC here, so you get the HF is here and the HF is here. Okay, so based on the HF, okay, so you sketch, then you sketch kat sini Ni atas, lepas tu sketch energy line. Okay, so DGL energy grade line. So hydraulic grade line for this V6 here, so we get the 64 point feet and 141. Okay, so you get the value of HGL. So maksudnya based on sini maksudnya based on that you find here HF4 and HP here. Okay, and the HP here, so you get the V6 based on 0.8. So dia ada perubahan dia lah berapa. Okay, so you get draw the, so you must sketch the EGL and HGL. Okay, now we look to find the pressure head at the suction side of the pump pressure head here. Okay, so soalan ni soalan final, the previous final, but the unit is in SI unit. So dia tukar pada SI unit. Okay, this is the real, okay, the reference book using the inch. Okay, so energy equation between A and B. Okay, B is at the P here, at the pump here. Okay, so energy equation between A and B. So you use the Bernoulli equation here, must include the pump here. Okay, so find the pressure head at the suction side of the pump. Okay, so they have actually the head loss and there are the friction loss only. Neglect the minor losses. So the HF is, okay, from this side. Okay, HF6. Okay, we just put the HF to this side. Okay, so that's why we get the negative here. Okay, so just put all the value until you get the PA is 0. Okay, ZA, okay, and VA is also 0. The HF6 is 4.281 feet here, and the pump here is we want to find the PB. Okay, so plus 50 here is ZB, and 0.8563 feet is VB squared over 2G. Okay, and you solve until you get the PB over specific weight. So you get this equation and you get the P. Okay, okay, PB and Y is this one, and then using the power delivered here. Okay, and you get the P power delivered to the water by the pump is here. Okay, compute the power of the jet. Okay, power of the jet using the jet here in pump here. Okay, so 1.458. Okay, 15.7 here. Okay, so you get the here. Okay, by pump to 80 by the jet here based on the jet 13.70. Okay, is based on the question. Okay, this you get the value 13.70. So you get the value here. Okay, so you get the P. Okay, untuk chapter 5 ni the banyak sikit so the calculation is more difficult. Okay, so you must know how to find. Okay, so kalau dia dalam SI unit senang so this is in feet, so you just study for this in SI unit try to find the question based on your reference book or so on. Okay, find using the SI unit only. Okay, saya tunjukkan based on this SI unit, sorry, US unit. Okay, so now we look at the, okay, now is branching pipe. Okay, so branching pipe is based on pipe parallel and pipe series. Okay, and also Hardy cross. So three. So let us consider three pipes connected to the three reservoir and branching together at common junction point J. Okay, so using the, from the tank A, the water flow to the pipe 1 here and the pipe 2 here and also the pipe 3. So they're the branching pipe. Okay, use from the tank, so they have the pipe 1 and then go to the pipe 2 and go to the pipe 3. So this is called branching pipe. Okay, so we shall assume that all the pipes are sufficient long that we can neglect minor losses. So we can neglect minor losses and velocity head. So HL is equal to HF, which we shall design it as H. Okay, so dalam branching pipe only, so we can assume that no minor losses, so just only have friction loss in pipe. Okay, so now branching pipe, so there are no pumps. Okay, in branching pipe is no pumps, so the elevation of P must lie between the surface of reservoir A and the C. Okay, if P is the level with the surface of reservoir B, then H2 and Q2 are both 0. Okay, if P is above the surface of reservoir B, then water must flow into B and Q1 equal to Q2 and Q3. So this is method for solution of branching pipe. Okay. Okay, branching pipe is actually based on pipes in series. Okay, so branching pipe tu just kita study saja. Okay, so in final is not include the branching pipe. Okay, so it's okay, we just study here. So example for, so if P is above the surface of reservoir B, then water must flow into B, and Q1 is equal to Q2 plus Q3. Okay, the Q1 plus Q2 is equal to Q3. If P is below the surface of reservoir B, then water must be out of B, and Q1 plus Q2 is equal to Q3. Okay, now we look at the example here. So they have the water at the tank A. Okay, go to the tank B and tank C. Okay, and branch to pipe 1 here, and the pipe 2 here, and the pipe 3 here. So this is pipe 1, this is pipe 2, and this is pipe 3. Okay, so the third pipe with diameter D3, and this is connection from D to reservoir C. Okay, water flow from reservoir A through a pipe with diameter D1 120 mm and length L1 102 meter until at the junction D. Okay, pipe with diameter D2 is equal to 75 mm and length. Okay, so dia ada tiga pipe. So they have three pipe. Okay, pipe 1, pipe 2, and 3. And from tank A, go to the tank B and go to the tank 3 AC here. Okay, so solution. So you must use the energy equation from A to B first. Okay, from A, you must using the energy equation base to B here. Okay, so you get the Bernoulli equation base A to B. Okay, PA over rho G plus VA squared over 2G plus ZA equal to PB density G plus VB squared over 2G VB, and include the HF1. Okay, HF1 plus the HF2. Okay, because you must include the pipe 1 here and also pipe 2 here. Okay, they must neglect the minor losses. So minor losses tak ada, they just only have the friction loss pipe 1 and friction loss pipe 2. Okay, so that's why we have the HF1 HF2 here. Okay, so PA and PB at atmosphere, this is 0 and also 0. Okay, so VA and VB can be neglected. Okay, so VA pun also 0, neglect juga. Okay, this is based on concept A you will have learned in chapter 3 and chapter 4. Okay, so they just only have ZA minus by ZB is FL1 V1 squared over 2G D1 plus VL2 V2 squared over 2G D2. Okay, so the ZA, ZB is this value, and F, this value L1, D1, L2, and D2. Just put in this formula until you get the V1 squared over V2. Okay, based on the 1. Okay, the formula of 1 here. Then using the for flow from A to C, then you use the A to C. Okay, energy equation from A to C. So as the same concept, so the A to C, they just only include the pipe 1 and the pipe 3. Okay, so in pipe 1, include the HF1, this is HF3. Okay, in pipe 3. Okay, so the ni pun sama so this is include the same method, also 0. So they just include ZA minus by ZS, sorry, ZC, 24F, L1, D1, L3, and D3. Okay, so you just put all the value in this formula, so you get the formula in 2. Okay, so V1 squared plus V3 squared. Okay, so flow and D. So flow and D at this part here, flow in D. Okay, so flow in D is equal to flow through DB plus flow through DC. Okay, from D to B, from D to C, from D here. Okay, so flow in D is equal to flow through DB plus the flow through DC. Okay, that's why we get the Q1 is equal to Q2 plus Q3. Okay, So this is concept of continuity equation. Okay, you have learned in chapter 3 and also the chapter 4. Okay, so this branch pipe, so flow in D, Q1 is equal to Q2 plus Q3. Okay, based on the Q1, this is Q2, this is Q3. Okay, maksudnya kat branching pipe here, so you must know that Q1 is equal to Q2 plus Q3. So you must refer to this solution here. Just put the 1, 2 here. You just put the 1 here. 1, 2 in this formula. Okay, so you get the V1 here in this 3. Okay, so you get the V1 in 3. Just substitute equation 1, 2, and 3. So the value of V1, V2, and V3 as you get the V2 here in terms here, and from 2, okay, from 2 here, okay, so you get the V3. Okay, substitute in 3 here, okay, substituting in here, so you get the here, and then you by try and error you will find the value of V1. Okay, so you get the V1 here and here. Okay, solve V1, so you get here. So flow rate at in AD, you get this option. Okay, and the V2 is this formula and this. Okay, so this slide I will give you. Okay, so no worry. Okay, don't worry. So this calculation for branching pipe is not included in your final. Okay, so this is just for your knowledge. Okay, so untuk pengetahuan you all saja how to calculate based on branching pipe. Okay, now you must refer to the okay, so you get the V1, V2, V3, and then Q3 also. Okay, fine here. Okay, now we look at the pipe in series. Okay, pipe series ni yang penting. So you must refer that the only two method that include in your final. Okay, pipe in series. Okay, and also pipe in parallel. Okay, pipe in parallel. Okay, so now we look at the pipe in series. Okay, so pipe in series based on two tank here, reservoir or tank here. They must include the pipe 1, pipe 2, and pipe 3. Okay, so the series, dia bersambung secara series. Maksudnya pipe 1, pipe 2, and pipe 3. Okay, so we have the EL energy line here and the HGL here. Okay, so based on the pipe 1, pipe 2, and pipe 3. Okay, so the basic assumption that you must know that for pipe in series is here. Okay, so Q is equal to Q1, Q2, this is Q1. This is Q2, this is Q3. Okay, untuk pipe in series, dia bersambung secara series. So total Q must include the Q1 is equal to Q2, Q3. Okay, yang branching pipe tadi dia kena tambah. The branching pipe you must plus. Okay, for the series, so must equal Q1 equal to Q2 equal to Q3. Okay, for the HL, okay, for the HL in pipe here. Okay, so the HL1 plus HL2. So total HL must HL1 plus HL2 plus HL3. Okay, so HL is must include the HF1 and the HM. So soalan sama lah. Okay, sebab dia must include. Tapi kena baca soalan betul-betul lah. So in questions, maybe they just mention them neglect minor losses. So neglect minor losses, no HM lah. Okay, kalau dia tak ada mention, so must include HF and the HM. Okay, so HL is HL1 plus HL2 and HL3. Okay, so now we look at the example here. Okay, a reservoir. Okay, So two reservoir were connected by a pipeline 1 and 2. So maksudnya the gambar dia, figure dia adalah this one. So this example 5.5, the example is based on two reservoir were connected. Okay, I draw lah. Okay, reservoir connected. Okay, two reservoir were connected by a pipeline 1 diameter and pipeline 2 2.55 255. So maksudnya daripada kecil ke besar. So pipe, so kalau figure tak diberi, you must draw. Sorry, 1, 2, 2. A to B So ni A to B. Ni pipe 1, pipe 2. Okay. Pipe 1, pipe 2 is D2 255. Okay, and length L2 is 50 meter length. Okay, D2, sorry, D1 150 mm and 1 is 6 meter. Okay, so calculate the rate of flow, okay, to find the Q, get the Q. Okay, and sketch EL and HGL. Maksudnya dia suruh sketch Take F is 0.01 for both pipe. Okay, so tak perlu nak refer. If F is given, so no need to refer to Moody chart. Okay, so inlet and outlet of pipe are categorized as a sharp. Okay, categorized as a sharp. So the K is for this entrance and also the out here. Okay, so now we look at the solution here. Okay, solution using the continuity equation. So we know that using the concept here, okay, based on Q1 is Q2 is Q3. Okay, so total Q1 is equal to Q2. Okay, based on the basic concept of pipes in series. So you know that if Q1 is equal to Q2. So A1, V1 equal to A2, V2. Okay, based on this basic concept. Okay, so you get the A1, V1, A2, V2. So we know that V1 is equal to A2 divided by A1 squared over V2. Okay, so you get the value 2.8. So you get from the here. Okay, so A1, V1, you must calculate based on the diameter 1, diameter 2, area 1 and area 2. So you must calculate the area 1, okay, and area 2. Okay, so you get the area 1 and area 2. Okay, and V1 squared over 2G. Okay, so you get the V1, okay, to get from this here. Okay, V1. So V1 is equal to A2 A1 V2. Okay, dia ada kuasa 2 ni sebab pi D squared. Okay, so pi D squared. Okay, so ada kuasa 2 because you must get the A, area 1. So you must get pi D 1 squared over 4. Okay, so you get lah. So A2 pun sama. A2 you get the pi D2 squared over 4 here. Okay, so you get the D1, D2 and we get the A2. Okay, so A1 squared over 2. So you get the, so nanti part ni akan mati. So they just only have the A1, 2 and you get here. Okay, so you get the 2.89 V2 here. Okay, so now we look at this is type of head loss. Okay, head loss is best referred to, this is entrance, so HE. Okay, HE entrance, and the sudden here, so the sudden here, and the H out here. Okay, and also the HF1 and HF2. Okay, so you have 1, 2, 3, 4, 5. So you have 5 head loss. Okay, 5 head loss. So you have the 1, 2, 3, 4, 5 head loss. So you have the entrance here, entrance here. Okay, entrance is based on 0.5 B1 squared over 2G. Okay, based on the H entrance. Okay, this is H entrance. Okay, you get 0.5 V1 squared. Okay, V1 squared over 2G. Okay, and 0.5. Okay, 0.5 times by V1 squared here, this one. Okay, V1, 2.89 V2 squared. Okay, squared here, ada kuasa 2 sini. V2 here. Okay, because just V1 is just changed to V2 here. So you get the V2 squared. Okay, so you get this one. And then for the fluid friction based on the HF1 here in the pipe 1. So you get the HF1. This is HF1. Okay, F1, L1, V1 squared, 2 squared over D1 here. Okay, so just put the F, L, and the V1 here, the value of V1, 2.89 V2 squared here. So you get the value of 3.34 V2 squared over 2G. Okay, we just, okay, kita stop, nanti kita selesaikan ni dulu, and then we stop, we can continue for Wednesday. Okay, so then we just continue so now in expansion. So expansion is at this expansion. Okay, this expansion. Okay, so H expansion. So as expansion is we just using the X, saya tulis X senang. Okay, so expansion using, you refer back to your chapter 4. Okay, V1 minus by V2 squared over 2G. So you dapat ni based on chapter 5, chapter 4. Okay, the formula for extension, sudden enlargement, okay, and so on. So based on chapter 4, okay. So V1 minus by V2 squared over 2G. So you get the value here. Okay, and you get the value. So V2. Okay, and the fluid friction for pipe 2, HF2. So this is HF2. So F2, L2, V2. This is V2. Okay, so 0.01 F. Okay, so F1 and F2 is the same, 0.01. L2 is, okay, length 2. Okay, and the velocity 2. Okay, so you get in terms of velocity 2. Okay, so 0.59 V2 squared over 2G. Okay, so exit. So exit is this one. Okay, so out, exit or out is, okay, this is out, exit. Okay, so exit or out. Okay, I mentioned here. Okay, out, H out. Okay, so V2. Okay, so total HM. Okay, so total HM is, you must plus here. So you must plus this one, plus this one, plus this one, and plus this one, and also plus this one. Okay, 1, 2, 3, 4, 5. Okay, 5 head losses. Okay, head losses include the HM and HF. So you just total up here. So you get the, sorry, this is not HM. So this is H losses. Okay. Okay, head losses here HL. Okay, so head losses. Okay, maksudnya head losses HL must include the HF plus HM. Okay, so that's head losses. The total up of these losses, you get the 12.94 V2 squared over 2G. Okay, ni baru kira head loss So this is just calculate the head loss. Then you solve based on Bernoulli equation between 1 and 2. Okay, between 1 here, 1 to 2. Okay, between A to B. Okay, between A to B. Okay, between A to B. Okay, so at the tank A and the tank B here. Okay, velocity 1, velocity 2 is based on the pipe 1 and pipe 2. Okay, so the PA and PB is 0, this is 0 also. And the V squared over is also here. Okay, so the kat sini V, this is at the V A. Okay, point A. Sorry, the point A or point B. Okay, so point A to point B. Sorry, point A, 1 to point A to point B, the pipe 1 and pipe 2 here. Okay, so we get the value here, Z1 minus by the Z2. Okay, Z2 is HL is 6. So mentioned here is the delta Z. Okay, delta Z is 6 meter. Okay, so delta Z, Z1 minus by Z2. Okay, Z1 minus by Z2 is delta Z. Okay, is 6. Okay, and the HL here, HL is based on the, you calculate based on this total out here. Okay, HL. Okay, so you just get here. Okay, and until you get the V2, okay, from this you just calculate the V2. Okay, so you get the V2 3.02 meter per second. Then you just put to get the Q. Okay, A2 V2. Okay, so you just put the value of diameter 2 and then just put the velocity 2. So you get the Q is 0.154 meter cubic per second. Okay, and the V1 is equal to 2.89 V2. Okay, you just put the value until you get the 8.73 meter per second. So this is the value of velocity 1. Okay, velocity 1. Okay, so any questions? Boleh So kalau tak faham tak apa. So if you don't understand, it's okay. So we can discuss more in the next class. Okay, now we look at the example 2 based on the 3 pipe. Okay, based on the 3 pipe.